All right, it is 9 a.m. We're going to get started here. Welcome to Advanced Kentucky's fourth week of online content review sessions for AP Calculus AB. My name is Aaron Timmons. I'm the Mathematics Content Director. I'm joined today by Michael Marshall, former AP Reader, current AP Reader, and our current Access to Algebra Content Manager, as well as today's presenter, Mr. Brock Strickland from Denver Public Schools. We are going to go over a couple housekeeping items here, and then we will jump right in. So first thing, this online review session is intended for a Kentucky audience. However, we know that there are lots of teachers and students from elsewhere in here, so we welcome you. We will do everything we can to make this an equitable opportunity to learn. During this session, we encourage participation, but any participants causing a disruption will be removed. Contact information for us can be found here. If you have any questions after today's session, please feel free to reach out to any of us. Give us a follow on Twitter or Facebook also. Your microphones for today will be off for the entire time, as well as your videos. We ask you to keep those off as well. Please use the chat feature in the bottom right-hand corner of your Zoom window. You can chat directly with Brock, Michael, or myself, or you can pose questions to the entire group, and we will be monitoring the chat closely. So any questions you have, if you are a teacher, if you are a student, anything at all, we will pose to Brock and get you an answer right away. Please make sure you visit kyap2020.com. That's where you can find the most current information that we are posting. Today's recording will be posted there along with all of our other recordings. You can also find other resources for both teachers and students. So right now we're going to take about 2-3 minutes here tops to, I'm going to pause the recording and I'm going to ask you to open up a different browser to go ahead and go to that bit.ly link there to sign in, please. It's a very quick 4 or 5 question Google form just to gather some information in case we need to reach back out to you. In the meantime, please make sure you've got today's handouts in front of you as that bit.ly/online capital C, capital R, capital S. And make sure you got your audio and everything working so you can hear us. So I'm going to pause the recording here for about 2 minutes, give you some time, and we will get started right away. All right, so hopefully you've had the chance to go ahead and sign in. I'm going to go ahead and turn things over to today's speaker, Mr. Brock Strickland. He joined us 2 weeks ago, and he's back for our week of free response strategies and mixed review. Brock, if you can introduce yourself, give us a little bit of your background, and then you can jump right in.
Fantastic. Thank you, Aaron. Good morning, everyone. Hope you're well. Happy Monday, and happy week 4 of these review sessions. So glad you're here, and thanks for joining us. So yeah, my name's Brock Strickland. I'm a senior team lead and math instructor at TJ High School and out of Denver Public Schools. And I've been a reader for the AP Calc exam for about 4 years now. So let's go ahead and rock and roll. Excellent. So let's see here. There we go. So like I was mentioning, this is CRS week 4. We're looking at free response question and exam strategies today, something a little more holistic rather than on a singular topic. I've mentioned my name and where I'm at, and that I've been a reader for the AP Calc exam for 4 years running now. Yeah, here we are, week 4, April 27th. And if you recall, we actually have been able to add a week this time next week, Monday, May 4th. We're going to be doing some more specific AP exam prep with Tony Record. He has been doing the Advanced Kentucky AP review sessions for Calc BC, and we're super thrilled that he can join us next week. And then I just want to give a proper shout out to Miss Melanie Gray for her excellent work in week 1 and week 3. She's been nothing but a collaborator and a teammate in this, and she's absolutely fabulous. I hope you enjoyed those sessions as well. So for today, we're already doing our introduction and overview, and so we're going to move right into free response question strategies, some ideas, and what I like to say is a little of this and that. Some notes from a reader who's been doing this for 4 years, because I can tell you, after the first year that I was a reader, I felt like I came back to my students with 2 to 3 additional points of free response, 2 to 3 additional points of what can be earned on free response. Not necessarily because of the calculus or the content, but because of the specificity in terms of what AP and College Board looks for in a full, complete answer. And so that's definitely some things we're going to talk about. And of course, we're going to look at this in the guise of some guided questions and specifically 2 free response questions. And we'll give you guys an opportunity to do some calculus as well. All right, that is our day. Let me go ahead and get out of this, and we are going to rock and roll into the 2020 AP Calc exam and strategies. Glad you're here. Okay. So just a cursory overview of what we're getting into. We're talking about the AP exam, which is going to be Tuesday, May 12th, 2 o'clock Eastern time. That's something you're going to log on for. And it's just going to consist of 2 free response questions. For question 1, you're going to have 25 minutes to work on it with 5 minutes to upload your response. And then question 2, more like a proper free response question from days yonder, just 15 minutes with another 5 minutes to upload your response. And it's, question 1 is going to be weighted 60%, and question 2 will be weighted 40%. And then this is what I wanted to talk about right here. Typically, free response questions assess topics from multiple units to begin with, but the scope of the question tends to stay within a specific topic or unit from what's listed on the College Board. We do not know how it's going to be changed this year, right? We're in uncharted territory here, but especially for question 1 being 25 minutes, I would really bank that we're going to be presented with a scenario, a situation, graph, table, equation, perhaps a combination of those last 3 that's going to go from perhaps something on continuity and limits to something that's from differential calculus, and then to perhaps questions from integral calculus, all within the same free response question. Now, again, this is just my working theory, but thinking that we've got 25 minutes for this first question, and the first 7 units of calculus are going to be encapsulated in just 2 questions rather than 6 plus multiple choice, I would really bank that we're going to see some broad topics and some broad scenarios of which we will be doing some differential and integral calculus within the same problem. So rather than thinking that, one question will be 1, maybe 2 units, we really should be mentally preparing to see one of our questions be so broad in its scope that we're doing many different types of calculus and mathematics from across the entire course. Some other course-specific info, just good to speak about. For students who prefer to type their responses on a computer rather than handwriting and photographing, College Board will provide a keyboarding tip sheet in advance of the exam. I was checking just this morning. I have not seen that posted yet. This is going to be a matter of preference for you. I think if you feel really good about your home Wi-Fi and being able to take a clean picture and uploading within those 5 minutes, my suggestion would be to do a handwritten exam, which is typically what students do every year. One thought I've had with the idea of typing answers into an online system is that, what if you forget a DX, or what if you're forgetting a parenthesis where it's necessary? And we're going to talk about some of those careless errors within this presentation. But if you're more comfortable writing and feel good about your home Wi-Fi, I would recommend stick with writing, take a picture and upload. But again, that's just a suggestion from me. It's a matter of personal preference for you and what you feel is going to put you in the best position to put your best foot forward on this exam come May 12th. So something to think about. Questions are designed such that a graphing calculator is not required. However, of course, it's an open note take-home exam, so of course you can use a calculator. To this end, think about the multiple choice section where you can use a calculator. 15 questions, and typically a third of those questions you need a calculator. A third of those questions you could use a calculator, but maybe not. And then the last third you actually can't use a calculator, it won't help you. We're talking about questions where you could use a calculator, but it won't be needed. And so something to consider. Of course, everyone loves having that graphing calculator by their side. It's a helpful tool, but make sure that it's just that, a helpful tool for you to use strategically and perhaps not to lean on. That's one thing just to really keep in mind. And then again, with the idea of an open book, open note exam, have your notes organized prior to the exam. Here's a link for you. I really like what College Board did in terms of open book tips. I will say open note exams tend to lean towards more conceptual questions than procedural. If I were a betting man, I would almost guarantee that problems presented and questions asked are going to be done in context. I don't think it's going to be something as simple as, what's f prime of pi? Right? Take the derivative, substitute in pi. I don't think it's going to be that straightforward. We're looking at things that are going to be more conceptual, and certainly questions that connect concepts as well. And this really has been the evolution of the AP Calc exam going back to 2001. If you look at previous free response questions, you're going to see that a lot of the free response questions in the early 2000s were more procedural. And if you look at the most recent free response questions, almost every question, with the exception of one or two, has some kind of contextual element to it with which you're applying the calculus to a specific situation. I definitely think we're going to be betting that we're going to see more conceptual questions, because this is going to be an open book, open note exam. Real quick, I just want to say that this first part of this presentation is going to be primarily lecture. I want to share ideas with you in terms of preparation and what's best in terms of how to answer free response questions, but better believe we're going to put this into practice. But I'm just saying right now, if at any point you have any questions, please put those in the chat, and Michael and Aaron will make sure to get those in. So, Dan Kennedy's top AP exam tips. This is something that's published online. These are some really good tips and just things to keep in mind. Number one, perhaps goes without saying, show all work. Remember that the grader is not really interested in finding out the answer to the problem. We are interested in seeing if you know how to solve. I tell my students all the time, if we focus on process, the product will take care of itself. If we're looking at how we get an answer, it will inevitably lead almost always to a correct answer. So rather than focusing on the product or the answer, focus on how you get that answer. And I promise the rest will take care of itself. But we are most definitely looking at process. And just to kind of give you an example, suppose there's 3 parts to a free response question, ABC. You can almost bet that there would be 1 point available for the answer, right? So that's 3 points. So that means that in a typical free response problem, there would be 6 points left to what we would say is process, showing an integral, showing a setup, having a proper justification, right? Do not round partial answers. Store them in your calculator so that you can use them unrounded in further calculations. And let me show you what I'm talking about here. We're going to go to the calculator here. Aaron, can we see the calculator?
No.
No?
No.
Oh, okay. I alt-tabbed. Let me stop this for a second. There we go. Okay, so good old TI calculator. One thing I want to show you. So let's use everyone's favorite irrational number, square root of 2. Okay? Now, suppose this were a limit of integration that I needed to use, right? I don't necessarily want to use just 1.414. I don't want to round an answer early in my process such that it's going to affect my answer down the road. So one feature that's incredibly helpful, it's right above the on button. It's a STO with a little arrow to the right. It's going to be store. So if I hit that button, previous answer store. So what are we going to store this as? Well, I'm just going to label this alpha B. And I'm storing this in my calculator as B. And so I'm telling the calculator, hey, we will forever know that long number as B. So for example, if I do 1 plus B, I should see 2.414213562, and boom. So that's what you want to do if you ever are working with irrational numbers or long drawn out decimals within the process of your problem. If I round this to 3 decimal places and I'm only in step 1 of a 7-step problem, that's going to affect my answer down the road. So I do not want to round answers early on. All right. Do not let points at the beginning keep you from getting the points at the end. If you can do part C without part A and B, do it. Too often students think that free response problems tend to start easy and end with the hard question. Now you can almost bet that there's going to be a easy, medium, and hard component, but they almost never go in that order. Question A might be medium, question B could be hard, and C might be probably some of the easiest work of that free response question. One note in this second sentence here, if you need to import an answer from part A, make a credible attempt at part A so that you can import the possibly wrong answer and get part C points. This is important because as AP readers, we are trained to read with you. If you need to import or bring an answer from another part of a free response question, and let's say you're taking an answer from part A and bringing it to part C. If you did part A wrong setup, wrong answer. But if you use that answer correctly for what is being asked of you in part C, you are eligible for full credit. Think of it as double jeopardy. We're not going to penalize you twice for the same mistake. If you make a mistake in part A or part B, and then you're required to use that answer in part C, so long as you use that numerical value that you imported correctly, both procedurally and conceptually, and it's good calculus, you will be eligible for full credit, which is great. Just as a teacher, I really appreciate that philosophy that we're not double penalizing you, or that if you make a mistake, you're not going to lose 2 or 3 points because of that one mistake. So don't let points at the beginning keep you from getting the points at the end. Every point is eligible and up for grabs and something that you can attain. And 4, if you use your calculator to solve an equation, write the equation first. An answer without an equation might not get full credit, even if it's correct. We refer to those as bald answers, and that's just the classic case where you write the answer and then the teacher hands you your paper back and says, show me your work, or how'd you get it? Write the equation first. Write your setups first. Believe me, those can definitely earn you points. And to that end, if you use your calculator to find a definite integral, write the integral first. Same concept. We're just talking about making sure that you are writing your setups. And I can definitely attest, at least for the past 4 or 5 years of AP exams, definite integrals and free response questions always are worth a point and sometimes 2 points. So even just writing your definite integral is something that's going to get you some points, okay? 6, 2 more. Do not waste time erasing bad solutions. If you change your mind, simply cross out the bad solution. Don't take time erasing it. Don't take time scratching out just one line through it, and readers are trained to disregard that work. So just cross it out. And then 7, just a friendly reminder to not use your calculator for anything except graphing, numerical derivatives to compute definite integrals and solve equations. Now, in particular, do not use it to determine max and min points, concavity, inflection points, increasing, decreasing, domain, and range. Those are all concepts that we can explore knowing a derivative or knowing the behavior of a derivative, but I really want to talk about just number 7 real quick. Do not use your calculator for anything except those 4 functions, and what I tell my students is, hey, math, not calc. So for TI users, use the math menu. And let me show you what I'm talking about here. I wish I could just Alt-Tab. So let's go back to the calculator. Okay, so right below the alpha button is the math button. That's where we want to live. And so, let's see if I can get a little, oh, nope, pardon me. Just seeing if we can get a little more, and that made it worse. That's a little better. Okay, we want to live with 8 and 9. And you know, for this calculator, it actually is fortunate that it shows this in the notation. That's where we want to compute derivatives. But suppose I go to second calc And we see the same features. We can calculate, mins and maxes, intersection points, but also derivatives at a point, integrals at a point. Please do not use this on the graph feature, okay? That's not where we want to be doing that work. We want to live in that math button. And the reason is, if I do second calc, the calculator is now taking the derivative or the integral with respect to the graph, and the pixelation can sometimes play into effect with how the value is computed. Said another way, it is entirely possible to have the exact same equation in y1, take the derivative, and then go to math 8, type that same equation, like y1, same value here, and get two different numbers. The most reliable, most precise answer is going to come from your math menu. I could go a little longer into this. I don't really want to spend time telling you why at this point. I'm just saying numerical derivatives and integration, math menu. Let me just show that again. And that's going to be math 8 and math 9. And then again for math 9, we see that integral right there, and we can just type everything in. So again, math, not calc. Math, not calc. Boom. Cool. All right. So far, so good. Yep, here we go. All right, so that's just kind of some general tips that, I have no doubt perhaps you've heard most, if not all, from your own calc teacher. Now, these are just 4 notes from me that I have passed to my students in terms of what is helpful and beneficial for the free response. This, by the way, is just a picture of one of the reading rooms when we all fly to Kansas City. We sit in tables of 16, and for 7 straight days, 8 hours a day, sometimes longer, we grade calc exams. It is simultaneously fun, but man, day 5, day 6, sometimes your life starts flashing before your eyes, let me tell you. Pronouns without antecedents. What? It's a math class, not a literacy class. Do not refer to anything in non-specific fashion. Use proper nouns. Let me give you a literacy context here. Go with me on this one. He woke up and was super excited for the day. As he was getting ready, he made breakfast, poured himself a cup of coffee, and couldn't help but just feel a certain level of anticipation for the first day on the job. Now, suppose I said to you, first question for a reading quiz, what's the guy's name? Can we assume who you're talking about? And as readers, we cannot. Instead of the function, write g of x, or whatever the function is named. If you write just the function, it is possible you cannot earn the full points, because what if the problem's talking about more than one function? Even if in the question stem it references g of x and you write the function, it's entirely possible, and dare I say even likely, that we could not award you full credit, because as readers, we cannot assume that you, the student, know that you are referring to a specific function. And so to that end, instead of the graph, write the graph of v of x. Instead of the derivative, write f prime of t. You kind of get the theme that we're getting at here. Specificity and proper nouns. To that end, define what you are referring to in explicit terms. Imagine telling a story about some friends and never saying he, she, they, or what is 100% the worst offender, it. Explicitly reference what you're talking about. Day 1 in my classes, if I hear a student doing an explanation and they say it, I stop them and I say, to what are you referring to? Just to build that habit. And so as you're building this habit, try to, get rid of the habit of saying pronouns. And if you catch yourself saying it, what are you referring to? Specificity of defining what you are speaking about is going to go a long way. And this is something that I didn't know. In my first year reading, I thought this was like, oh, this is good to know, because grading my own students, the function, the graph, the derivative, I'm their teacher. It's like, oh, I know what they're talking about, right? They're my students. I know. But when you get to a national and global level of grading and consistency, we as readers are taught that we cannot assume to know what the student is referencing if they don't explicitly reference it. G of X, not the function. The graph of V, not just the graph. State what the derivative is. Cannot enunciate this enough. There are so many points that students have lost because, again, we can't assume that they know exactly what they're talking about. That's tough. That's tough. Equal signs and linkage errors. I think this is one perhaps your teacher has mentioned to you, but if you're going to write a series of quantities from left to right in succession, connecting them with an equal sign, every quantity must be equal. My recommendation here is rather write your work below for each step, and in your final step, show your conclusion perhaps with an equal sign. But as soon as you are linking things in different quantities in succession with an equal sign, you gotta make sure everything is equal. And this is referred to as linkage. Any linkage error we see is an automatic 1-point deduction. Sometimes that 1 point is what we call banked, meaning if you have a linkage error in part A, but you continue to make linkage errors in parts B, C, and D, you're not going to keep losing 1 point. You'll just lose 1 point, and that's it. But I have seen cases where linkage errors can create multiple point deductions depending on what we say is the philosophy of the question. So it is possible to lose 1 point and then have that be it, but it is also possible to lose 1 point for every time there's a linkage error in multiple parts of a question, and that can just be devastating. If you've got 9 points up for grabs and you lose 3 points for linkage, it's just a drag. It's just a drag, for lack of a better phrase. So really, don't. My recommendation: don't be writing from left to right. Write from top down, and then in that last step, throw in that equal sign there. That's just going to prevent you from any potential linkage errors. Careless errors, they exist. Reread your own work. No doubt you've heard this advice before. But just some things that we see quite frequently: the top offender, the magical reappearing and disappearing negative sign. Yep, we've all been here with that. 4 times 3 is not 7, it's 12. But of course, as we're rocking and rolling and in the zone of testing, sometimes we make these careless errors. Read your math for comprehension, not numeracy. And let's go back to just this simple equation up here up top. 4 times 3 equals 7. Now, that right there, I'm just reading for numeracy. 4 times 3 equals 7. And perhaps if I'm not thinking about what multiplication means, I might even still gloss over this. Don't literally reread your work. Read it for comprehension. Okay, 4 times 3, 4 groups of 3 is, whoa, that is not 7. 4 groups of 3 is 12. Hang on, let me fix that. When I say read for comprehension, you could literally read a novel and read the diction out loud, but if you're not thinking about it, if you're not visualizing that, you're not reading for comprehension. Mathematics can very much be the same way. What is your process and writing talking about? Does it validate a literal, logical flow of connecting thoughts? And so read your math for comprehension, not just numeracy and procedural processes. Because again, sometimes if you're reading too fast, or if you don't have enough time and you're kind of starting to feel under the gun and that anxiety kicks in, you still may gloss over an error like this. And that's just nothing but a don't type of error. And lastly, this is coming from me, the best justifications, rationales need only be one and only, error there, only one sentence. The left Riemann sum is an under approximation as the values described in the table for P of t are strictly increasing. R of x is continuous at x equals 3 because the limit of R of x as x approaches 3 is equal to R of 3. The graph of f has a point of inflection at x equals b because f double prime changes sign at x equals b. This is the last one, and so we're going to move on to some calculus in just a hot second. You guys are doing great. Thank you for your attention, and thank you for your engagement. This is not an exclusive idea. Of course, more verbose and perhaps multiple sentence explanations and justifications can earn full credit. It's just that as a reader, I have found that the more you write, the more you, the student, are trying to just making sure you're throwing up whatever and hoping something sticks to the wall. And sometimes it works. Sometimes when you're writing so much, unbeknownst to you, you end up contradicting something in the problem or even yourself. And as soon as you state an incorrect statement, you lose a point. It's the same philosophy as the linkage error. If you are describing two quantities as equal and they're not, that's a linkage error. If you verbally or linguistically describe something that is incorrect or contradicts something in the problem, that is a logic error and you lose a point. I begin to coach my students and in the beginning of the year, I straight up use sentence stems and everything. I know it's perhaps a little elementary, but it's something I really believe in and coach my students for. The best justifications are only one sentence. What is the answer? Why? What did you compute? How'd you get it? Right? One sentence. It is the confidence of a writer who knows precisely what they're talking about. And so when you catch yourself writing and writing and writing and writing, it's almost always because you don't have a keen, firm grip on the conceptual knowledge, and now you're just writing what's popping in your head, hoping something sticks to the wall. And again, that's possible, but at the same time, if you do that and you contradict something, which I've seen happen, certainly that becomes something where you earn an error. So, as far as free response question tips, that's what I've got. It is 7:35 my time. Let's see here. Let's do some calculus. Gosh, enough of me. Okay, so let's see here. Oh, come on now. Oh. Let's fix this. Ah, that froze. Hang on one second. My .cam app just crashed, but that's an easy fix. Okay, here we go. Aaron?
Yes.
Hang on one second. My window has changed here. No longer have the ability to share a screen. Hang on. Oh, heck. Oh, there we go. Okay. Hitting buttons.
Crisis averted.
Crisis averted. All right. Let's do some calculus. Holy cow, this guy doesn't know what he's talking about or doing. All right, so a couple things. One, 2014, but notice, question 5. I'm going to be the first to tell you that this is a non-calculator question and perhaps may not be as applicable to the calculator work that you're going to see, but here's the point. I've got F prime, G prime. I've got multiple values listed and multiple intervals listed, and as we progress through this question, you're going to see that there are several cases where we need to justify or explain. So this is more about putting some of those strategies that we've talked about into place. So the twice differentiable functions, f and g, are defined for all real numbers x. Values of f prime, g, and g prime for various values of x are given in the table. Find the x coordinate of each relative minimum of f on the interval -2 to 3. Justify your answers. Aaron, I think it's a good place for our first poll question. What do you think?
Coming right up.
So, what is the relative minimum of f? Let's take about 75, 90 seconds here.
So everyone is encouraged to participate. These are completely anonymous questions, so no harm, no foul. Feel free to put out your best guess.
Love seeing those votes come in. Good on you, everybody. Thank you for the engagement. Happy Monday. Beautiful day to do some calculus. That's been about a minute. Let's take another 20, 25 seconds or so, and then we'll talk about this. All right. Thank you, Aaron. Yeah, so we're going to be looking at one. So happy no one selected 3. Now, if you selected -2, -1, no harm, no foul. That's why we're here. Let's talk about it. So I am going to start with the justification in here. Now, you need not necessarily do that. This is a calculus exam, not an essay or anything like that. So, I mean, whether you start with your justification and lead into your answer, or state the answer first because, and then have your justification statement, that's perfectly fine. Now notice, I started F attains a relative min where F prime changes from, okay, minimum. Let's connect that back to F prime. Changes from, yeah, you got it, negative to positive. Okay, this is a perfect justification statement. We just need to state our answer as well. F attains a relative min where F prime changes from negative to positive. Therefore, F has a relative min at x equals, yeah, it's going to be 1. Let's take a look at that table here, right? F prime. So we've got some specific values right in there. But notice the derivative is negative, and certainly that validates F decreasing from 12 to 8 because we have negative slopes. So we would be decreasing. F prime is negative from -1 to 1. Then at 1, we see the derivative is 0, and then it changes to positive. So this is where we see that derivative changing from negative to positive. -1 would be a good distractor because we see the derivative equal to 0, but remember, it's not just where there are critical points, it's where the derivative changes sign, and for a minimum, we need to be considering how the derivative changes from negative to positive. We see that happening at x equals 1. And so again, just to go back to our statement, F attains a relative min where F prime changes from negative to positive. Therefore, F has a relative min at x equals 1. Boom, one sentence. Now, number of different ways this sentence could look. We could even say F has a relative min at x equals 1 because F prime changes from negative to positive at that x value. Great. But notice, I'm stating F. I'm not saying the function, right? Especially because now we're talking about F prime, G prime. If I just say the function, I can't assume that you are talking about the function even if it's referenced in the question, right? For question A, it speaks specifically about F, so we need to state F. So just something to consider. All right. Moving on. And again, if you have any questions, please send those questions my way, all right? All right, here we go. So B, explain why there must be a value C for -1 less than C less than 1 such that f double prime of C equals 0. All right, so explain why there must be a value C on an interval such that f double prime of C equals 0. Hopefully when you see a question stated like this, we're going to the mean value theorem. Now, here's one note that perhaps I probably should have made a slide for, but I wanted to talk about this here too. When we're talking about mean value theorem or intermediate value theorem, we need to state the conditions for why for why the mean value theorem applies. So let's go back to this prompt, the twice differentiable functions f and g. So we can say, since f and f prime are differentiable, what's the conclusion that we can make? If a function is differentiable, or if two functions are differentiable, those two functions must be, what's that word we're looking for? Continuous. State that condition, because in order for the mean value theorem to apply, our function must be continuous on the closed interval and differentiable on the open interval. Now, the differentiable open interval is given to us in the prompt, but we also need to state that these functions are continuous. That's going to get you one of those points. Now we can go right into our mean value theorem. So we're saying, hey, the second derivative evaluated at C, the instantaneous rate of change, must be equal to the average rate of change on that interval A to B. We're essentially saying if C is in between A and B, the instantaneous rate of change is equal to the average rate of change on that interval. And so we know that A and B are going to be -1 and 1 respectively. So we're going to say, okay, f prime of 1 minus f prime of -1 all over 1 minus -1. And then we go right to the table. F prime of 1. So here's the derivative. 1, we're looking at 0. So back here, I'm going to say, let's see here, 0 minus, I'm going to put a 2 at the bottom there because we know 1 minus -1. And then pulling from the table f prime of -1, that's 0 as well. And we can say, hey, 0 minus 0 over 2 is certainly equal to 0. So, lastly, have I fully answered the question? Explain why there must be a value C. Do you think this is a full explanation as to why? Not quite. So, I'm going to draw a little box here for our explanation. And so we're looking for the mean value theorem concludes there must be one value C on the open interval, -1 to 1, such that f double prime of C is equal to 0. There's our explanation why. Here's the calculus that proves it off to the left, right? Here's our setup. We're now substituting in our open interval, and then of course exporting values from a table. But then we need that explanation statement that just says the mean value theorem concludes there must be one value on that open interval such that f double prime of C is equal to 0. And then again, mean value theorem, intermediate value theorem. Just remember, if a function or functions are differentiable, they must be continuous as well. And that is a condition for both of those theorems. Stating that is definitely something you'll need to do.
And Brock?
Yes, Aaron.
I think it's good that you know, sometimes wordy sentence there at the end just comes straight from the stem on part B there, for where they write their concluding statement. They can just pretty much copy word for word what it's asking them to do for their explanation.
Yeah, Aaron, I appreciate that comment. You're absolutely right. I mean, use what's given to you, right? You know, you've got some good notation here. You got the premise of the question. And also, notice the implication of the stem. Explain why there must be a value. That means there is a value. This isn't a question of, is there a value C? The prompt says, explain why there must be a value. So we know we're working towards a value of C that allows this condition, this dependent clause in our question, to be true. And so really it kind of comes down to, do you recognize an open interval? C is almost always the variable that is used to denote mean value theorem. And then of course, F double prime of C equals 0. Aaron, thank you for that. That's a great comment. Let's rock and roll to part C. We are getting a little short on time, but you guys are doing fabulous. So the function h is defined by h of x equals natural log of f of x. Find h prime of 3. Show the computations that lead to your answer. What is h prime of 3, everybody? I'm going to get started on this just a little bit. What's that rule for natural log? Let's take another minute. It's been about 30 seconds. About another 30 seconds. We're going to come back together in about 10 more seconds. All right, Aaron, I think we can show those answers now. Yeah, we're looking at 1/14. Congrats to those who got that. If you selected 2 7 through 7 halves, hey, great mistake. Now's the time to make those. Let's talk about it and see how we got to 1/14. And I appreciate, again, just everyone, you know, and your engagement. So over here on the left here, I've got our initial setup here. Now, recall that the derivative of natural log of u with respect to u is simply just going to be du over u. So back to our problem. If u is f of x, okay, so thinking now h prime of x, we know f of x would be in the denominator of that derivative. What is the derivative of f of x? Well, conceptually, isn't it just f prime of x, right? I mean, that's all we can state. We actually don't know an equation that f of x is equal to. We just know it in notation form. So, I mean, the derivative of f is just f prime, the derivative of f. And now we go off to h prime of 3. Now, wherever I substitute a 3 in for x, I got to do the same thing over here on the right. So it's going to be f prime of 3 all over f of 3. And now we're back to our table. So h prime of 3, f prime of 3. So let's see here. There's 3. F prime, that's going to be 1/2 all over f of 3, which is 7. And then, guys, I really can leave my answer like that because remember, this is a calculus test. It's not an arithmetic test or an algebra test. We don't need to combine like terms. We don't need to simplify numerical answers. So really, if you left your answer just like this, you earned full credit. Everything is beautiful. But of course, we could say, hey, 1/2 over 7, that's equal to 1/14. That would be 1/2 times 1/7, 1/14. But again, once you get to all numerical values, let the work speak for itself. The reader is trained to accept any numerical composition that would arithmetically lead to a correct answer. Again, it's a calculus test, not an arithmetic test. And so once you're down to this step, you're good to go. But yeah, it's going to be 1/14. So I've got part D in the folder, and I've got the answer key there. I'm going to let you examine that on your own, just because I do want to get to our last poll question, which I believe was 3B. So let's see here. Yep. So this is going to be our closure, okay, because we got about 6 minutes left. So there are 700 people in line for a popular amusement park ride. And by the way, this is 2010. It says question 3, but this was before we went to having only the first 2 be graphing calculators. So this is a graphing calculator question. I think it was starting in 2012. Only questions 1 and 2 were a graphing calculator question. So there are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate, R of t, at which people arrive at the ride throughout the day. Time t is measured in hours from the time when the ride begins operation. So, B, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. Aaron, you want to go ahead and put that last poll question up? There you go. So you've got answers and a justification. What makes most sense? We'll take 90 seconds. We'll talk about this. We're going to come back together in about 20 seconds. All right, Aaron, shall we reveal?
Okay.
Aaron, I might have been an error in the communication. The answer I think we were looking for was the last one, increasing because R of t is greater than the number of people exiting the line. That might have been a formatting error on my part. Because yeah, Aaron, does it show that like the answers are decreasing?
No, those are just highlighting which ones were selected the most.
Oh, okay. Forgive me. Thank you for that. So the answer that we're looking for is the last one. So this is great. This is an excellent conversation piece for our closure because again, mistakes are wonderful. We want to be making mistakes at this time. We want to be learning from them and applying that knowledge going forward. So really, really good job. So let's talk about this concept here. Okay. First things first, R of T represents the rate at which people are entering the line. Now, notice, people move on to the ride at a rate of 800 people per hour. So if people are moving on to the ride, really we can interpret that as people who are exiting the line. We've got the rate in and we have the rate out. If you were joining us 2 weeks ago for my presentation on fundamental theorem, think of it as, we got a rate in and rate out. So we need to determine, okay, is the total number of people in line increasing or decreasing? Well, our interval given to us is 2 to 3. So from time t equals 2 to t equals 3. Now, look at the rate at which people are entering the line. At 2, we're at 1,200. And right at 3, we go to 800. So if there's in between 1,200 and 800 people at any given point entering the line in between 2 and 3, yet there's only and always only 800 people exiting the line in between 2 and 3, we can say R of T is greater than 800 on the interval 2 to 3. More people, the people entering the line is greater than 800 for any given point on 2 to 3. So essentially more people are entering the line than exiting the line on 2 to 3. So we say therefore the number of people entering the line, waiting in the line is increasing. More people are entering the line than exiting the line, because as we see here, this represents the rate of people entering the line. It's going to be in between 1,200 and 800 at any given point, yet always 800 people are exiting the line. So more people are entering the line than exiting. Therefore, we say the number of people waiting in the line is increasing, and that justification statement, R of T is greater than 800 on that interval, earns us the full point. So it's understanding, this is a great question for our closure. I know we're just about out of time, but again, your take-home AP Calc exam is going to focus, I'm willing to bet, on more questions like this because they are conceptual. So it's understanding what is being presented to you. My goodness, thank you so much. Let's see here. I'm gonna stop my share. Real quick, just give me 30 seconds to say that it is April 27th. Your exam is not until May 12th. I really hope each and every one of you are spending anywhere from 20 to 45 minutes a day studying. I hope you go back to previous units, learned everything we know about neuroscience suggests that learning is more ingrained when you connect it to previous concepts. And I just want to say, I think you all are going to do so fantastic. The fact that you are taking the initiative to be here on a Monday morning says so much about your desire to perform well and do well on the AP Calc exam. And so I just wish you the best of luck, the best of preparation, and come Tuesday, May 12th, from just, a stranger in Denver, Colorado, I say, y'all got this. Thank you so much for your time. Aaron, I'm going to kick it back to you.
Thanks, Brock. Very good job.
Thank you, Brock.
Yeah. I'm going to share my screen here and just go over quick closing details. So again, if you have any questions for Brock, Michael, or myself, feel free to reach out to us. Brock did a tremendous job. I think those tips he gave are ones that Michael and I would agree are definitely emphasized during the readings and are well worth taking credence in. If you have questions about the links or the handouts, feel free to go to kyap2020.com. Today's recording will be posted there by the end of the day. As Brock mentioned at the beginning, we are going to have an extra week next week right before the exam on Tuesday, this time Tuesday at 1 p.m. We'll be joined by Tony Record. So we're very excited to have him. He'll have a lot of good tips, I'm sure, to share as well. And then those of you that are teachers that are administering the mock exam for us, the window closes this week, and then our reading will be next week. So please make sure you have any sample responses submitted. If you don't know what I'm talking about, go to kyap2020.com for more information on mock exams for all AP Math and Computer Science courses. So unless Michael or Brock have any other closing remarks, we're going to go ahead and sign off, and hopefully we will see you here next week.
Nope, just want to say thank you, everyone. Good luck. Great preparation ahead of you. May 12th, you got this. Thank you, Michael. Thank you, Aaron.
All right. Thanks so much. We'll see you all next week.